Okay, properties of exponents. I'm going to start with the odds first, and then we'll go and do the evens. All right, so first thing I want to point out is that you got to pay attention to the parentheses. When they have a parentheses and a power, so for instance here, number 3, the -2, the -2 applies to the negative inside the parentheses and to the 5. So just kind of making my point, if you look ahead to number 5, the next one down, so we have x to the 5th. The 5 only applies to the x. It never ever sees the negative or the y, right? The 5 only applies. So the parentheses definitely mean things, have very specific meaning. So make sure you're paying attention to the negatives. If there's parentheses or if there's not parentheses. So back to number 3, the -2 applies to the negative and it applies to the 5. So if the exponent is applying to the negative, there's only 2 possible outcomes. Either the negative will stay or the negative will go away. The way we remember that is we look at the even or oddness of the exponent. So -2, I don't really care that it's negative. What I do care about is that it's even. 2 is an even number. So when it's even, the negatives will go away, right? Because a negative times a negative is a positive. And if you do it an even number of times, it'll always be positive. Therefore, it'll go away. If it's an odd number, then the negative will stay, regardless if it's a -2 or a negative exponent or a positive exponent. It's odd and even. That's what you're looking at. So we have the negative going to go away because of the -2, it's even. And then y, 5 times -2 is -10. Times, again, the -2 is going to apply to the x squared. We multiply x to the -4 because 2 times 2. Okay. The last step is you always clear the negative exponents by moving them to either up or down, depending on where they are. Well, right now, it's implied that they're over 1. You would never see it like that, but it's implied, it's understood. So the y to the 10th is going to go down, and then x to the 4 is going to go down as well. And so what's left in the numerator? Right, a 1. Right, if everything moves down, then it's just a 1. And it doesn't matter if it's x to the 4 is first or second, right? This y10 x to the 4, like it's being multiplied. It means the same thing. All right, number 5. So negative y x to the 5th times, so this -3 is going to apply to everything in the parentheses. So x, -3 times -3, +9, y, -12. Okay. Common bases. So there's the negative in front, so that's going to be a negative. Common bases, right? So y times y, we add the exponents. So this is going to be y. 1 plus -12 is -11. Then x. So 5 plus 9, 14. So clearing the negative exponents, we have negative. What's left up top? X 14, because that's positive. And then y to the 11th goes down into the denominator. All right, 7. Again, the x to the -4. The -4 will never ever see the negative in front. Right? It has 0 effect over the negative in front. So negative x to the -4. There's literally nothing we can do at this point. the -1 exponent will apply to everything in the parentheses. It'll apply to the negative sign, the x4, and then the y to the -5. Okay, so the negative to the -1 power. Is the negative going to stay or is it going to go away? Well, 1's a odd number, so it's going to stay. Regardless if it's -1, right? Regardless. So this is negative, and then x to the -4, 4 times -1, 5, y to the +5. Again, the negatives cancel. -5 times -1 is +5. Okay, this all being multiplied. So simplifying it one time, we have negative times the negative. Those are going to go away. X to the -4 times x to the -4. So I'm looking for all the common bases, right? So this is x, -4 plus -4, -8. And then y to the 5th. There's only one y. Okay, clearing the exponents, negative exponents, we have y to the 5th in the numerator over x to the 8 in the denominator. Okay, number 9. First thing I see is v to the 0. Anything to the 0 is 1, right? If it's 1, we don't care about 1s, it cancels. So v to the 0 goes away. The square is going to apply to both of these. So u to the -6 because -3 times 2. V to the 4 because 2 times 2. And then times -u to the 4. And obviously the v to the 0 goes away. Okay. Combining common bases. So the random negative sign will go to the front, just because I always bring the negatives to the front. And then u, -6 plus 4, -2. V to the 4. All right, clearing the negative exponents. We have negative v to the 4 over u squared. Okay. Number 11. Here's a fun one. So I'm going to deal with inside the parentheses first. That -4 can chill outside. I'm going to deal with this. So anything to the 0 is just 1. Doesn't matter if it's one thing or a bunch of things. Anything to the 0 is 1. So that goes away. We don't care about that anymore. Okay, inside the parentheses, we have y to the 4, or not y to the 4. We have y, x to the 4th on top. And then, so y, x to the 4 over negative x squared, y squared. Okay, so here's one way to think about this. I have one y in the numerator, 2 y's in the denominator. Right, because y squared, that means y times y. Right, that's what that means, y squared. So if I cancel out 1 y in the numerator, 1 y in the denominator, I'm left with 1 y in the denominator. So there's a y left in the bottom. And that's the same as doing top minus bottom, which would be 1 minus 2. Then you get y to the -1 up top, but then you have to move it. So if you think ahead, I guess, it's easy to just scratch numbers out, right? 1 y in the numerator, 2 y's in the denominator. So the way I would have done this, the y cancels up top, the cancels out the 2, leaving behind a 1. Again, I don't care about 1s. The x's, there's 2 x's in the denominator, 4 x's up top. So 4 minus 2 is 2. So we're left with x squared. and then the random negative, which you could put out in front or you can leave it in the bottom. Don't matter. Technically, not technically. Personally, I want to move it to the front. So that negative can basically just move to the front. All right, and this is all to the negative fourth power. So the only, I guess, bad thing about just scratching out numbers is sometimes it can get convoluted, right? It'll be hard to read because you're like, what did I scratch out or what's left behind? Things get lost. So you just make sure you're keeping everything straight. Okay, the negative 4 has to apply to the negative, has to apply to the 2, and has to apply to the y. Okay, the negative in front, it's going to go away because 4 is an even number. So I don't even care about the negative in front anymore. We have x, 4 times 2 is negative 8, over y, again, negative 4. So we clear the negative exponents. The y will move up, the x will move down. So this is going to be y to the 4th over x to the 8. All right. Is that it? That is. All right, number 13. Handling the numerator only. The 4 is going to apply to the negative, to the 5, to the negative 2. So negative to the 4th power, it's an even number. 4 is an even number, so it's going to go away. X to the 5 times 4 is 20. And then y, negative 2 times 4 is negative 8. All over. So in the denominator, just looking real quick. Okay, so there's a random negative just thrown in there. So that negative is going to come out to the front. So I can move the negative out front. So negative. That's that random negative in the bottom. Okay, common bases, x's. We add exponents. 4 plus 2, 6. So x to the 6. Y's, negative 4 plus 4 is 0. Y to the 0. I don't care about that. Okay, simplifying. So there's the negative in front. The numerator we have, so there's 20x's on top, 6 on the bottom. So top minus bottom. 20 minus 6, 14. And then y to the negative 8 up top, that's going to move to the bottom. So y positive 8. Okay, that's that. $15. Okay, looking at just inside the parentheses first. There's a v cubed on top, v cubed on bottom. So those cancel, making a 1, right? They just go away. There's a u in top, u in bottom. That's going to go away. So what's really left behind? We have v to the negative 4 over a negative. Technically, it's negative 1. All to the negative 5th power. Okay, simplifying this. First off, I can bring the negative out front. Then the v to the 4th, negative 4, that's going to go down. So v to the 4th on bottom, leaving behind just a 1 up top. You never want to just leave it blank. Like, there's always a 1 there, no matter what. If everything leaves, it's always a 1. And then to the negative 5th power. Okay, the negative 5th power is going to apply to the negative. It's going to apply to the 1. It's going to apply to the v4. So simplifying this, we have, so is the negative going to stay or go away? Correct. It's going to stay because 5 is an odd number. So negative, and then 1 to any power is just 1. Then v 4 times negative 5 is negative 20. So simplifying clearing the negative exponents, we have negative v 20, right? It just moves up to the numerator. And then we don't care about over 1. All right, 17. We have numerator only. Negative 2 times 4. X, negative 8. Denominator, so there's a 2 in there. Combining common bases, so x negative 1 and x, which is just 1. So negative 1 plus 1 is 0. So x to the 0. That's nice. Why? Because it goes away. Y to the negative 3 times y. So this is y, negative 3 plus 1, negative 2. All right, simplifying this, we're going to get, all we do is clear the negative exponents. So y squared moves up, x to the 8 moves down, and then the 2 is still in the bottom. Okay, last one for the odds. It's kind of misleading because we have to do a whole nother side. Okay. The numerator, there's nothing we can do at the moment. 2yx. X cubed. All right. And the denominator, x to the negative 3, y to the negative 2. Right, nothing we can do. However, this parentheses, we can. The 3 is going to apply to the 2, apply to the 4, apply to the negative 2. So this is going to be times 2 cubed, which, I get it, it's 8, but let's just leave it like that for the moment. And then x12, because 4 times 3, y negative 6, because negative 2 times 3. All right. So combining what we can in the denominator, we're getting 2y x cubed over, so common bases, x's we have, well, I'm going to put the 2 cubed up front. And then now the common bases, so negative 3 plus 12 is 9. Negative 3 plus 12. For the y's, negative 2 and negative 6 make negative 8. Okay, simplifying this. First off, there's a 2 in top, 2 cubed in the bottom. So that's going to mean 2 squared, which is 4. Okay. This y to the negative 8, that can move up. Right, it just moves. All right, combining the numerator, y times y to the 8 is y9, because 1 plus 8 is 9. All right, the x's, you could do top minus bottom, right? 3 minus 9 would be x to the negative 6, and that'll move down as positive 6. Or you could think of it as there's 3 x's up top, there's 9 x's in the bottom, so then that becomes a 6. So then cleaning it all up, right, you have y9 over 2 squared, which is 4, x to the 6, and that's it. Okay, might have to watch that a couple times before you can apply the rules comfortably. So that's the odds. So let's do the evens. We're at 19 minutes. Let's go. Okay. The 3 is going to apply to the A, apply to the B. So this is a cubed. B, negative 2 times 3 is negative 6 times negative a b squared. Okay, the negative is going to go to the front like normal. Common bases, a cubed and a. Add them, a4. B negative 6, b2. Again, we add them. So this is going to be b negative 6 plus 2 is negative 4. So clearing the negative exponents, we have negative a to the 4 over b to the 4. a4 over b4. And a negative. All right, 6. Looking at just the interior, the inside of the parentheses, what can we do? Negative times a negative, that's nice. 2 negatives go away. Common bases, x negative 3, x negative 3. So we're going to get x negative 3 plus negative 3, negative 6. And then a single y. All right, this is all inside a cube. So when we apply the cube to everything, we get x negative 18 because 6 times it's 3, y cubed. Clearing the negative exponents, final answer, y cubed over x 18. All right, number 8. Okay, the negative 5 exponent is going to apply to the negative. It's going to apply to the 0. It's going to apply to the 2. All right, first thing, anything to the 0 is 1. So that goes away. So I don't even care about that one. All right, so when the negative 5 applies to the negative sign in front, 5 is an odd number, so the negative is going to stay. So there's a negative out front. The 0 goes away, it's a 1. And 1 to any power is 1, so I don't care about that. V, negative 10, because 2 times negative 5. This is times negative u to the 5 power. Simplifying this, again, negative times a negative goes away. V to the 10, negative 10, that's going to move down. So V to the positive 10, U to the 5 up top. So V to the 10 is in the denominator because it was negative. All right, number 10. Okay, Y5 can't do anything. X and negative 3 can't do anything. So for the moment, those are just there. All right, negative 2 will apply to the negative 3. Negative 2 will apply to the 4. So this is going to be X, negative 2 times negative 3, positive 6. Y, 4 times negative 2 is negative 8. Okay, so applying the common bases. So Y's, so Y, 5 plus negative 8 is negative 3 times the X's. So X, negative 3 plus 6, positive 3. So final answer, again, clearing the negative exponents, we get X cubed over Y cubed. All right, 12. 12 is a fun one. Check it out. So just looking at the inside only. Anything to the 0 is 1, goes away. Anything to the 0 is 1, goes away. Okay, there's a y squared up top, y squared in bottom. So those go away. So what's really left over? Inside this thing, we have y to the 4th. That negative that's in the bottom, that can just be pulled out to the front. And then the x to the negative 1 is in the denominator. I'm going to move that up. and then all to the negative 4 power. So simplifying first here really helped out. All right, the negative 4 is going to apply to the negative in front. The negative 4 is going to apply to the 4, and it's going to apply to the x. So negative 4 is even, so the negative is going to go away. Y to the negative 16, because 4 times negative 4. X, again to the negative 4. So clearing the negative exponents, both of them are negative, the y and the x, so they're going to both move to the denominator. So y16, x to the 4, all under 1. Right? Anytime they both move or everything moves, it's just a 1. So yeah, it's very important that you understand that the exponent always applies to the negative when there's a negative. It always applies to the negative. All right, 14. We're almost done. Well, not really. 14. Numerator only. We have a negative. Now, I mean, if you pause the video and just work it out and you do you, but I'm doing this like the way that my mind processes things. So the negative is going to go to the front. X to the 5th. Y to the negative 4. Right? There's nothing I can do. So there's something I do. Negative 4 plus 1. Negative 3. Right? Because negative 4 plus 1 is negative 3. All right. And then that's all we can do in the numerator. Denominator. Square is going to apply to the 5. It's going to apply to the 5. So x to the 10, because 5 times 2 is 10. Y to the 10, because 5 times 2 is 10. Okay, simplifying here. A couple different ways you could do this. There's a negative, right? A single negative that can just go to the front. All right. You could do top minus bottom, right? 5 minus 10 is negative 5. Negative 5 will move to the bottom. But look, there's 5 x's up top. There's 10 x's in the bottom. So there's going to be 5 left over, right? Like they cancel out. So x to the 5th in the bottom. All right, with the negatives, or with the y's rather, it's y to the negative 3 over y to the 10. So negative 3 minus 10, top minus bottom, gives us y to the negative 13. That's in the numerator. It's going to move down. So y to the positive 13. Now, another way you could have done this, we'll say, okay, hey, I'm going to move this negative right now. And then when you multiply y10 times y cubed, you add the exponents, making 13. That's another way also. And of course, there's a 1 up top. All right, 16. Looking at, again, just the parentheses. X to the, anything to the 0 is a 1. That goes away. There's a y cubed in the... Actually, look, there's a 2 up top, 2 in the bottom. That's going to go away. There are 3 y's in the numerator. And there's 8 y's in the denominator, right? 4 and 4. So that's just going to become a 1. Right? Because there was 4. I took 3 away. All right, so let's clean this up. So inside the parentheses, in the numerator, there's nothing left, right? So it's a 1. Denominator, what do we have? A y and a y4. So you add them. 4 plus 5, or 4 plus 1 is 5. And x to the 4. I'm going to write it in the front. X to the 4. All of this to the negative 4 power. Can't forget about that. Okay, the negative 4 exponent is going to apply to the top, which is easy. And it's going to apply to the 4. It's going to apply to the 5. So this is going to be 1 to any power is 1 over. So x, 4 times 4 is 16, so negative 16. 5 times 4 is 20, negative 20. So all of that is in the denominator. Clearing the negative exponents, we have x to 16, that moves up. Y to the 20, that moves up. And we don't care about over y. You don't really say over y ever. Or over 1, sorry. Okay. 18. This one looks hideous. All right. So first thing that jumps out at me is this y to the 0. Anything to 0 is 1, so I don't care about that. And that's really all we can do in the bottom. So in the numerator, however, let's see. Let's combine all the common bases. So here's a 2 and here's a 2. So those are just going to go to the front. So 2 squared. Yeah, you could put 4. I'm going to say 2 squared. Just as a technique, that's just how I do. All right, what else? We have y's, y's, y's. So we add all the exponents. So 1 plus negative 3 plus 4. So 1 and 4 is 5. 5 plus negative 3 is 2. So y squared. And then all the x's. So here's an x, here's an x, here's an x. So 3 plus 2 plus 1, 6. So x to the 6. And all of this is going to be to the 4th power over 2x cubed. All right, the 4 up top is going to apply to all 3 of these exponents. So this is going to be 2 to the 8 power, because 2 times 4. Y to the 8 power, again because 2 times 4. And then x 24, because 6 times 4. All over 2x cubed. All right, simplifying, we have 2 to the 8 on top and a single 2 on the bottom. So we can cancel those out. And that'll leave behind a 7. So 2 to the 7th power. So 2 to the 7th is going to be 2 times 2 is 4, 8, 16, 32, 64, 128. So 128. Y to the 8. And then there's 3 x's in bottom, 24 on top. So top minus bottom, 24 minus 3 is 21. So x to the 21. Yeah, that one's good. All right, last one. Under an hour. Awesome. Okay, simplifying just the inside. Now, I mean, could you, in theory, apply the 2 now? I mean, yeah, you could. It's just, why would you do that? All right, looking inside, we have a 2 on top, 2 on bottom. So that's going to cancel. We have, that's all the obvious ones. So looking at just the numerator, x to the negative 3, okay. Okay. Y to the negative 2, y2. So negative 2 plus 2, is 0. So y to the 0, which is nice. It's nice. Anything to the 0 is 1. All right, denominator in the bottom, there's a y and an x squared. Okay, and all of this is going to be squared. So one last simplification, something you could do. You could say, okay, x cubed in the bottom, because you clearing the negative exponent, right? Like I don't want that up top. So we just move it to the bottom. So really, in the parentheses, what do we have? In the numerator, everything went away. So it's just a 1. And then in the denominator, we have y, x to the 5, because 2 plus 3. And all of this is squared. Okay. The square is going to apply to the 1. It's going to apply to the y. It's going to apply to the x. So 1 squared is 1. Well, 1 to any power is 1. Y squared. And then x to the 10, because 2 times 5. I think that's it. Did we get it? Did we win? Yeah, we did. All right. Hopefully this helped you out. Good luck.